It seems like every device we own is now connected to the internet. There's a term for that, Internet of Things, the subject of today's episode. Welcome to Kopek Explains Software, the podcast where we make computing intelligible.
All right, so this week we're going to talk about the Internet of Things. What do we mean when we say Internet of Things?
It's a very amorphous term, that you can basically say any device that's not your personal computer, your smartphone, your tablet, is an Internet of Things device if it's connected to the internet. One way that I like to think about it that makes it a little more clear. Think about something that a decade ago would not be connected to the internet, but that today when you buy, oftentimes is connecting to the internet. So if you think about our household, Rebecca, and you think about the things we've bought over the last few years, what are some things that are connected to the internet that would not have been 10 years ago?
Well, I would say definitely our washing machine and our baby monitor are the two that really come to mind. Would our Alexa devices count as being part of the Internet of Things?
Yeah, people think about those as Internet of Things. I'd also say our security cameras. We had security cameras for our dog to kind of monitor our dog during the day. Those were internet connected. And now we have a security system for our home. It has sensors all over our house. All of them are connected to the internet through a hub device so that the police or the company can be alerted if there's anything unusual going on. So we actually have a lot of Internet of Things devices just in our household, and we're not even like super into this movement. There's some people who've gone and connected their whole house, every light switch, every thermostat, every appliance is an Internet of Things device.
I feel like there are movies where someone's in a smart home and then the home kind of attacks them, turns against them. Is that where we're headed?
I'm not worried about being attacked, but I certainly think our privacy is at risk with all of these devices to some extent. They're all proprietary for the most part. Some of them are not, but most of them are. And they're all sharing our data all the time with big tech companies. And so we do need to think about, well, okay, how is our data being used? What kind of things are being monitored? Do we trust these companies? All things that need to go into the equation every time we acquire another Internet of Things device. Now, the different big tech companies like Amazon, Apple, Google, they have their own Internet of Things kind of home device platforms. For those of you that are familiar with Apple, you're probably familiar with things like HomeKit. Amazon and Google have equivalents as well. They're ways of managing all of your Internet of Things devices so that you can, through their digital assistants like Siri or Alexa, talk to all of your Internet of Things devices from one platform. And so every device manufacturer that makes an Internet of Things device for your home needs to ensure that it's compatible with the protocols that Apple and Google and Amazon specify. And when you buy a new Internet of Things device, you can check, does it work with Alexa? Does it work with Apple's product line? Some products work with only a couple of them. Some of them work with all three of the big players. They're working on more unified standards. We haven't yet gotten there. But hopefully in the future, we'll have devices that will just need to implement one standard and be able to work with all of the three major tech companies. But whichever ecosystem you're buying into, whether you're buying into Apple's ecosystem or Google's or Amazon's, you have to basically trust that company with your data. And they know a lot about you. For example, we even have a lamp in our baby's room that's connected to Alexa. And every time we go and turn it on or off, that data is basically being sent up to Amazon. So yeah, I don't think we need to be afraid of our homes, but I do think we need to be aware of what's going on and how much of our lives and information is being collected.
What's actually inside these devices that allows them to connect to the internet? Like their Linux systems?
Yeah, we did a previous episode on what is Linux. So if people don't know what that term means, I'll put a link in the show notes to that previous episode. But a lot of these systems are running Linux. They're of course embedded computers. So every single device that connects to the Internet of Things has a computer inside, as do almost all electronic devices. Basically, any electronic device you buy today has some kind of really simple microcontroller inside of it. Almost every device. Some are still analog. And there are two different kinds of these embedded computers. Some of them are extremely simple. They have really basic microcontrollers, which are basically really simple microprocessors. They have really small amounts of memory, and they don't even run full-fledged operating systems. They run just simple firmware, simple software that can run in a very constrained environment. They use almost no electricity. They create almost no heat. There's a whole nother slightly more sophisticated class of devices that actually run Linux or other real operating systems. They tend to have faster microprocessors, something more similar to what might be in your smartphone of a few years ago. They tend to have more memory, and they tend to have more capabilities for more sophisticated software. So you'll see both of these inside Internet of Things devices. You'll see really simple microcontrollers, and you'll see full-fledged embedded computers running Linux. Whichever one it is, it's going to run a lot of custom software. The device manufacturer is going to go and write software just for that one device that's either running on top of Linux or running basically on raw metal on top of these really simple microcontrollers. So there's a lot of work that goes into producing software for these very bespoke platforms. And it's not really software that can be reused in other contexts. It's very specific to the device. For example, our washing machine, right? Think about it. The software has to understand how the washing machine works. And there also is this really proprietary, specific to the washing machine user interface. We have a screen on top. It has, I think, there are touch buttons that go with that screen. And they don't relate at all to any other kind of computing platform. They are specific to that washing machine. This, of course, introduces the possibility and the frustration that our devices can actually have software bugs. We just did an episode last week on tragic software bugs. But one of the things that's not quite as tragic, but is unfortunate about the modern software world is more and more of our devices are susceptible to software bugs because more and more of our devices run on software. If we bought a baby monitor 10 years ago, it wouldn't have had any software on it probably. It wouldn't even probably be digital. It would just be analog, sending an analog radio wave signal with the images from the camera going to a little TV-like device. If we bought a washing machine 10 years ago, it might have a simple microcontroller in it. It might not have even had a simple microcontroller in it, and it probably wouldn't have any software to speak of running inside of it. So we're opening ourselves up to not only the possibility of bugs in all of these devices, we're actually also opening ourselves up to security vulnerabilities potentially. You could think about your car today. Many cars are connected to the internet as Internet of Things devices. There's been stories about people hacking into cars. There's stories about people hacking into security cameras like we have in our house. We're opening ourselves up to a whole world of hurt with the Internet of Things. Why are we doing it? It's for convenience, of course. It's nice that, for example, with our baby monitor, we can also go on our smartphone, connect over the internet, and see what is happening if we don't happen to have the physical baby monitor device with us at all times. It's nice if you have one of those internet-connected thermostats in your house that if you forgot to turn the heat off and you go on vacation, you can go on your phone and turn the heat down. So we're trading off complexity in the sense that now there's an additional part in all these devices. There's additional software that needs to be built. There's additional possibilities for bugs and for security vulnerabilities for convenience. But I have to say the convenience is really nice. I love being able to connect to the baby monitor from my phone. I love being able to look at my security cameras anywhere I am.
I can start my car from inside my house. Would that count as an Internet of Things?
Yeah, that's the thing about this term. It's so amorphous, right? Basically, anything that is not a traditional personal computer, smartphone, or tablet is considered an Internet of Things device. Sometimes people think this is like some really specific term, that it has some really clear definition. It doesn't. It's more like a movement. It's Internet of Things. It's things that were previously not connected to the internet that now are. So yeah, I would, in my own definition, consider your car part of the Internet of Things. It's a thing that's connected to the internet. Therefore it is. And there's people who go and study this. There's whole classes about it. Where I teach, we have a class about the Internet of Things. It's about how do you build embedded software for a very small microcontroller that might go into some device that's not a personal computer or a smartphone or a tablet.
Is it something that's hard to build for or program for?
So if you're programming for an Internet of Things device, you have a few things you have to keep in mind that wouldn't be true on a smartphone or a laptop. Mainly how limited both the software and hardware environment is. If you're working on a microcontroller, so not even a Linux-based embedded computer, you're basically working on raw metal. So you have to manage the power, you have to manage all the devices yourself. There's not a lot of software libraries that are working underneath the covers to help you do that. So you need to be more in tune with the hardware as a programmer. You're also working in a much more constrained environment. You have a lot less memory to work with. You have a much slower microprocessor. The reason is to keep costs down and also to keep the heat down, right? The faster the microprocessor is, the more heat it generates, the more electricity it uses. These devices, having embedded computers in them, need to create as little heat and use as little electricity as possible, ideally. And also, the microcontrollers are a lot less expensive. That's another big factor of all of this. You might think, wow, how much is it adding to the cost of my washing machine that it has a microcontroller inside of it? Well, not that much. A lot of these microcontrollers, when they're mass produced, cost less than $1. Then you add in maybe the cost of the touch screen that goes on the device, and that makes it a little more expensive. But we're not talking about a huge percentage of the cost of the overall device. So if the washing machine is $600, my guess is in the average $600 washing machine that's connected to the internet, the computer parts of it are going to be less than $20 at most. And the microcontroller itself might actually be less than $1. So it's not adding a huge amount to the cost of the device in terms of physical components. Of course, there's also the cost to the company of producing the software. And like I mentioned earlier, this software tends to be extremely device specific. So while they might be able to use some open source components, some components from previous devices, there's a lot of custom software being built for every one of these Internet of Things devices. And I think that research and development, that expense of building the software, is probably one of the most difficult and expensive components for companies building Internet of Things devices.
But for the home programmer, someone who maybe wants to prototype a device, that's not that hard to do.
It's actually easier than ever. There are some open platforms like Arduino that allow hobbyists and even professionals to very quickly get an Internet of Things embedded computational device up and running. It's very easy to get started with Arduino. You can go and purchase an Arduino-like device, plug it into the USB port of your computer, download a program on it, and then in a few minutes you can have some LED lights blinking. In a few hours or a few days of learning, if you already have some programming experience, you can start to be using that microcontroller to run some motors, to be controlled by some switches. You can really get very far very quickly. And there's well-known programming languages that people can come in that they already have experience with and go get up and running quite quickly. For example, Arduino's main language is based on C++. There's a very popular alternative called MicroPython, which is a stripped-down version of the Python programming language. So it's really easy today to get started prototyping, building a hobbyist Internet of Things device. And these same tools like Arduino, are actually being used by professionals as well in the prototyping phase, and even launching in some commercial products. We mentioned earlier that there's also embedded computers running Linux that are in a lot of Internet of Things devices. Well, one of the most popular learning platforms for computing today is the Raspberry Pi, and that's an embedded Linux computer. And you can buy a Raspberry Pi for just $35, the low-end device. And actually, if you want to buy one of the embedded devices, they started as low as $5. So you can get started for not very much money very easily with a Raspberry Pi on a more sophisticated Internet of Things device. So it's easier than ever for the hobbyist programmer or the company that needs to do some prototyping to get started in this space.
That's pretty cool. It's fun to think about people creating and inventing their own things with these computers being more and more accessible.
Yeah, I'd say the thing that's not fun about all of this is how now we as consumers need to learn all of these different interfaces. Every device we have to figure out how do we get it connected to Wi-Fi, and everyone has a different interface, right? I'm hoping that as Apple, Google, and Amazon unify their efforts and start to make it even easier for us to get our new devices onto our existing networks, we're going to really get to a point where we're not dealing with these separate interfaces with every device we buy. The other thing is now we have to worry about software updates. Like I was thinking the other day, our baby monitor wasn't working so well. Do I need to update the software on it, right? How annoying is that, right? Every device, your washing machine, your baby monitor, your car, you're updating the software on it on a regular basis. What kind of bugs are happening? What kind of security vulnerabilities are there? I never had to worry about that 10 years ago. And it adds a whole new layer of complexity to life, a whole new set of worries, really, if you know about this stuff. The reality is, though, if someone hacked into your washing machine, is it likely anything that bad is really going to happen? Probably not. Is it that dangerous if someone gets in your washing machine? I guess not. If someone hacks into your car,
that could be very dangerous.
That could be a little more dangerous. And so, yes, there are new worries, but look, as a species, we always like convenience over security to some extent, right? You've seen it in so many things as modern life has evolved. If we didn't like convenience, we wouldn't drive cars, right? So horribly, so many people die in car accidents every year, right? How many people die of their washing machine getting hacked into? Not that many, but we are exposing ourselves to security vulnerabilities. How many people have died so far of their cars getting hacked into? I don't know the answer to that question, but my guess is it's a very low number, if not zero. So it's a real danger, yes, but at the same time, we need to keep things in proportion. And you can't stop the march of software. We talked about in our trailer the famous quote that Mark Andreessen said, software is eating the world. Well, software is certainly eating all of our appliances. It's eating our cars. It's eating basically anything that turns on with electricity that's around us. And if you're interested in getting into a really cool field, I think this is a really great job opportunity. If you're thinking about becoming a programmer or a software developer, they need people in embedded software development more than ever. So it's a really exciting field because there's so much of our world that's being changed by it.
So after all that, what really is the Internet of Things?
It's just anything that's connected to the internet. So anything that's not your smartphone, your tablet, or your personal computer that's connected to the internet is what people call Internet of Things. They're running embedded computers. They have bespoke software handcrafted for every single individual device. It does add bugs, it does add security vulnerabilities, but it's introduced so much convenience into our lives that it's hard to go back.
I'm not giving up my smart washing machine anytime soon.
It's nice to get notified when it's done. All right, well, thanks for listening to us. Rebecca, how can people get in touch with us on Twitter?
We're at Kopec Explains, KOPECEXPLAINS.
And thanks for listening, and we'll see you next week.
Bye.